10th D Electrical Circuits and Safety. 10th.16 Series and Parallel Circuits. A circuit may contain more than one electrical load, and those loads can be connected in different arrangements. Two basic arrangements have specific names that describe the current path through two or more loads. In a series circuit, the loads are connected one after the other in the circuit path. There is only one path for the current to follow. All the charges from the source flow through all the loads in sequence at the same rate. For example, if two or more light bulbs are connected in a series circuit, figure 1036, the charges that pass through the first bulb must also pass through the others. Therefore, the same amount of current flows through all the light bulbs. If any one bulb burns out, the circuit is broken and the current stops flowing through all the bulbs. In a parallel circuit, the loads are connected in separate branches of the circuit. The current flows through more than one path, splitting up to flow through each load. The individual currents recombine on the other side of the parallel portion of the circuit. For example, if two or more bulbs are connected in parallel circuit, figure 10-37, each bulb represents a separate path for charges. The current from the supply conductor divides, and only a portion goes through each bulb. The amount of current running through each bulb in a parallel circuit depends on its resistance, according to Ohm's law. If the bulbs all have the same resistances, the currents are the same in each. If one of the light bulbs in the parallel circuit is turned off or burns out, current will continue to flow through the other branches, and the bulbs will continue to burn. For this reason, building codes require that electrical fixtures and receptacles in houses be wired in parallel. 10.17 Short circuits and overcurrent protection. A current takes the path of least electrical resistance back to its source. This characteristic often causes electrical appliances to break down. The electrical supply cords to appliances have at least two wires in them. The wires are the conductors to and from the appliance. If the cord's insulation is damaged so that two wires touch, most of the current will bypass the appliance, taking a shortcut where the wires touch. This condition is a short circuit. Short circuits are dangerous because the current bypasses the load, which normally keeps the current at safe levels in the wires. A wire can carry only a limited amount of current. In the previous section, we introduced a power equation that relates current and resistance. P equals I squared R. Doubling the current running through the wire quadruples the electrical energy converted to thermal energy in a resistance. If current in the wire increases too much, the heat released can melt the insulation and start a fire. Short circuits are the most common cause of electrical fires. Circuit breakers. To prevent currents in faulty circuits from starting fires, building codes require that every electrical circuit in a building have overcurrent protection. A typical house has between 10 and 40 circuits to protect. Each circuit has a circuit breaker connected in a series relation with the load. A circuit breaker is a switch that is manually closed, but that automatically trips open if the current flowing through it exceeds a set value. Each device is rated for a certain number of amps, its amperage, clearly stamped on the breaker switch. Circuit breakers are installed in a central panel that must remain easily accessible at all times. Circuit breakers are reliable, easy to use, and reusable after the circuit fault has been corrected. A relatively new type of circuit breaker detects very high short-duration currents caused by arcing, which usually accompanies short circuits. Electrical arcing occurs when electricity jumps tiny gaps between segments of a conductor. These faults are particularly hazardous because the hot sparks can ignite flammable materials that may not be touching the wires, and the wires may not draw sufficient current long enough to wires due to short-trip a standard circuit breaker. These protective devices are called arc fault circuit interrupters, AFCI. They are intelligent, often containing microprocessors that can detect an arcing short circuit. For homes built after 1999, all circuits supplying bedrooms are required to be protected by AFCI circuit breakers. Fuses. Older homes with original electrical wiring may have protective devices called fuses rather than circuit breakers. A fuse is a metal and glass container with a thin strip of metal inside that allows current to flow from the supply to the load. The thickness and material of the metal strip determine the fuse's amperage. It screws into a fuse panel near where the electricity enters the building in series with the circuit it is to protect. If an electrical fault in a wire causes the current to exceed the rating of the fuse, the metal strip melts, creating a gap in the circuit. When the fuse blows, the current stops flowing. Fuses are far less convenient than circuit breakers because the fuse has to be replaced after the problem is corrected. Also, it takes time for the current to melt the metal strip in the fuse. This delay may result in wiring damage and even allow a fire to start. 10.18 Electrical shock and ground fault. Protection. If you have ever experienced even a small electrical shock, you appreciate the importance of protecting people from such shocks. It may take tens or even hundreds of amps to start a house fire, but it takes only 0.2 amps or less to paralyze your heart, which uses a complex set of tiny electrical signals to control its beat. You are exposed to hazardous voltages when insulation in a wire or an appliance fails. If you touch a faulty electrical appliance, your body could become part of a circuit. Special devices called ground fault circuit interrupters, GFCI, protect against shock in exposed locations. They monitor currents between the wires, supplying an appliance or outlet. As long as the currents remain balanced, the circuit is considered safe. When the GFCI senses a current imbalance, it instantly opens the circuit. A current imbalance occurs when a person, grounded to the earth by touching a metal fixture or standing on a wet surface, touches an active appliance with an electrical fault. He becomes a conductor of electricity and unbalances the current in the electrical circuit, activating the GFCI. A GFCI device is usually a special outlet, but it can also be part of a portable extension cord. You may have seen GFCI outlets in your bathroom or kitchen, recognizable by the two small test and reset buttons. There are also GFCI circuit breakers that monitor entire building circuits, not just individual receptacles. As the lightning rod has done, modern electrical safety devices continue to protect human lives from the consequences of living in a fallen world. God has given humans the knowledge to design these tools. Using that knowledge does not thwart God's judgment, but instead shows love to one another and glorifies God.